Okay, so today you're going to learn more about logs. First, let's just try these two examples here about exponential functions and their inverses, so what we did last time. Number one, given f of x, which is just 5 to the x, find the inverse. So I taught you that last lesson. We're going to switch the x with the y and solve for y. So now I have x equals 5 raised to the y. That's in exponential form. So to solve for y, we're going to write it in log form. Log base 5 of x is equal to y. So that's the inverse. Log base 5 of x. So that would be the inverse of f of x. Letter B wants you to find f inverse of 125. So basically here in the inverse, if you replace the x with 125. So I need to do log 5 of 125. So I'm just replacing the x in the inverse with 125. So that, you should be able to evaluate these by now. That's just 3. If you can't visually evaluate it, then remember the way you would solve that is you set it equal to x, or actually maybe let's not use x because we don't want to get confused. Okay, let's set it equal to a, and then you would do 5 raised to the a equals 125 because you can change it to exponential form, and now you would just rewrite 125 with the base of 5, so that would be 5 cubed. So now we can see the answer is 3 for sure. Letter C, same thing. Looking at the inverse, go ahead and replace the inverse, replace the x with 1 over the square root of 5. This would be log base 5 of 1 over the square root of 5. Now that one's harder to see. I think the answer is going to be like a negative 1/2. But again, that one's harder to see. So for that one, I would definitely let's set it equal to a and change it to exponential form. So I'm going to write 5 to the a equals 1 over, instead of putting the square root of 5, let me put 5 to the 1/2. Because that's the square root of 5. And now, this fraction of 1 over 5 to the 1/2, I can just write that as 5 to the negative 1/2. Because if it's a positive exponent on the denominator, I can move it to the top and make it a negative exponent. So 5 raised to the negative 1/2 is the same thing as 1 over 5 to the 1/2. So the answer was negative 1/2. And that's just a little review of inverses. Let's try it again on example 2. You have f of x, which is 2 to the x. And then you have g of x, which is log base 4 of x. Those are not inverses. They're just two different functions. So let's try some function evaluations here. Let's do g of f of 5. Okay, first of all, let's do f of 5. So f of 5, I'm going to replace the x with 5. So f of 5 is 32. Or you can leave it as 2 to the 5th. So now I need to do g of that. So I need to do g of 32. In order to do g of 32, I need to go to the g function and replace that x with 32. Okay. And now that I can't do in my head. I'm going to go ahead and change it to, set it equal to a and change it to exponential form to solve. Because we need to figure out log base 4 of 32. It's going to be a fraction. So let's set it equal to a and change this to exponential form. 4 raised to the a equals 32. But like I said, let's write as 2 to the 5th, because that's 32. And then also let's write 4 with the base of 2. So instead of putting 4 here, let's write that as 2 squared. So now I have a base of 2 raised to the 2a, and I have a base of 2 raised to the 5th. So you can just set the exponents equal to each other. So we can say 2a equals 5. So my answer is going to be 5 halves. Solve for a. Let's keep practicing. Letter B, the open circle there, that's just the same notation as letter A, but it has an open circle. So let me just rewrite letter B as f of negative 1. That's what the little open circle stands for. So you just write f, replace the open circle with parentheses, of f of negative 1. Now let's just do the same thing with it on letter A. We're going to find f of negative 1 first. So let's do f of negative 1 equals 2 to the negative 1, which is 1 half. Now I need to find f of that answer. So now I need to find f of 1 half. So again, that should just be 2 to the 1 half. And that's going to be your answer. You can leave it like that, 2 to the 1 half. Or I think on my answer key, I put it as the square root of 2. They're both correct. And they're both equivalent. So 2 to the 1 half or the square root of 2. They're the same. And last one, letter C. Letter C wants you to do g of f inverse. Okay, so first of all, let's find f inverse. So f of x is 2 to the x. So if I want to find the inverse, I know it's going to be the log base 2 of x. And you can find the inverse like I showed you on number 1. Switch the x and the y, and then solve for y. So it would be log base 2 of x. Okay, so now I need to do, replace the x on the inverse with 16. So let me do this. So f inverse of 16 will be log base 2, 16. That's an easy number. That's just 4. Log base 2 of 16 is just an integer, 4. So that's just equal to 4. And now I need to do g of that. So I need to do g of 4. So now I need to do g of 4. So to do g of 4, I need to go to the g function. So log base 4 of 4. And that's also an easy integer. It's just 1. Log base 4 of 4 is 1. So final answer, 1. All right. So those, make sure you come back and practice them again. How to evaluate functions with exponentials and logs. For homework tonight, I think you might see some of those, so just do your completion homework on the online book. And now for some log properties. Here's some log properties that you're going to have to memorize. There they are. So there's 3 properties you're going to have to memorize. Actually, there's one more that I forgot to write down. I'll show you. But here they go. So when it comes to logs, let me start it this way. If you have a log of whatever base of m plus another log with the same base of n, you can combine both of those logs into one single log by multiplying your m times n. Same thing, or the opposite when it comes to subtraction. When you have two logs that have the same base, you can combine them into one single log by dividing your m over n. And then the next log property is when you have a log that has a coefficient, like 3 log or whatever, or 4 log, whatever, that coefficient can become the exponent of your m. So it can be m to the n. It becomes an exponent. And then the last property that I forgot to write on here that you do need to know it because it's on your homework tonight is when you have a log base whatever of m, that is also equivalent to the log base 10 of m divided by the log base 10 of b. So add that to your log properties. So when you have a log of whatever base of m, that's going to be equivalent or the same as log base 10 of m over log base 10 of b. Or natural log. So let me do that one too. So again, if you just have any log with any base, that's the same thing as the natural log of m divided by the natural log of b. So that's the last log property that you'll need on your homework tonight. So now let's use some of these properties to do some examples. Make sure you memorize the properties for the next test, the test next week. Number 3, using the properties of logs, write each of the following as a single log. So right now I have 2 logs that are the same base that are being added. So I'm going to combine them together by multiplying. But first, both of those logs have a coefficient. So I'm going to rewrite that coefficient as the exponent first. So for example, instead of writing 2 log base 3 of 5, I'm going to change that 2 and make it the exponent of 5. So it would be log base 3 of 5 squared. And you can just leave it as 5 squared, or you can change it to 25. And then over here, instead of putting 4 times log base 3 of x, I'm going to change that 4 and make it the exponent. So now this is log base 3 of x to the 4th. Now I could combine them into one single log by multiplying the 5 squared times the x to the 4th. So this is going to be log base 3 of 25x to the 4th. You can put 5 squared if you want, but 25x to the 4th, that's better. And that's how you use the properties of logs to combine them into one single log. So let's keep practicing. Number 4. You have a bunch of logs that don't have a base, which means the base is 10. And then you have just a single integer here. So this integer, which is just this 2, we need to write that as a log base 10, because all of these are a log base 10. So instead of putting 2, I'm going to write that as log of 100. Log of 100 is the number 2, is integer 2. So now I have log of 100 plus, okay, what's happening here? plus a 1/2. Let me combine these two logs in parentheses into one single log. Since they are being added, I can just multiply the 3 and the x together. So log 3x. Okay, the rest I'm just going to leave it minus log 7 minus, I'm going to write that 2 as the exponent. Minus log z squared. Okay, so I started simplifying a couple things. Like I said, I changed the integer 2 to log of 100. I combined the log 3 plus log x as log 3x. And then I just changed the coefficient of 2 and made an exponent for z squared. Now I have to keep going. Let's make this 1/2 coefficient as the exponent here. And let me combine these first two logs. Again, since those are being added, I can just multiply the 100 times the 3x to the 1/2. We have to be careful. So this is going to be log of 100 times 3x to the 1/2 is actually the square root of 3x. Because you're taking the whole 3x and raising it to a 1/2. So now I have log of 100 times the square root of 3x minus that minus log 7 minus log z squared. And you can do that in less steps if you want. I'm just showing you all my steps. So the next one I'm going to do are these first two. I'm going to do the log of 100 times the square root of 3x minus the log of 7. So these two logs can be combined into one single log by doing the minus. So I'm going to divide. I'm going to go ahead and divide the 100 square root of 3x over 7. So let me combine these. So these would be log of 100 square root of 3x over 7 minus the same stuff still, minus log of z squared. So finally, I'll do it one last time to get them into a single log. Now I have another two logs that are being subtracted, so I also just need to divide all of this fraction here by the z squared. And since I have a fraction already, I can just, when I need to divide by z squared, I'm just going to put the z squared on the denominator. So for my final answer, here it goes. It's going to be a log of 100 square root of 3x, and then on the denominator I have the 7, and I'm going to have the z squared. Because it was being subtracted, so it needs to go divided on the denominator. So number 4, final answer. Log of 100 square root of 3x over 7 times z squared. And like I said, you can do that on less steps if you want to, but I just showed all my work. So let's keep practicing combining these into a single log. I think 4 was the hardest one. The rest are easier. Number 5. Let's change the coefficients as exponents. So let's get rid of that 5 and put x to the 5th. Let's get rid of that 1/3 and put y to the 1/3. And now, since those two logs are being subtracted, that means you can combine them into a single log by dividing x to the 5th over y to the 1/3. So my answer will be log 4 of x to the 5th over, I'm going to change it to the cube root of y. Or you can leave it as y to the 1/3, it's the same thing, but cube root of y is what I like better. And that can be our final answer. You don't have to rationalize anything when it comes to these logs like that. That's the final answer. So we'll do one more. Number 6, 2/3 log base 6 of 7. Change that 2/3 as the exponent. So I guess that would be the answer. Log base 6 of 7 raised to the 2/3. That's an acceptable answer. Or if it's multiple choice, you might see it as log base 6 of, I'm going to change this fractional exponent as a radical, cube root of 49. The reason why it's a cube root of 49 is because the denominator of 3 becomes the root, and then the square, you have 7 squared, which is 49. So those are, just make sure you know that those are equivalent, because you'll see some true and false questions on your test. They're equivalent. And that's how you combine logs into one single log. I'll pause for questions. Okay, so let's continue practicing these property of logs. Now we're going to do it backwards on example 7 and 8. So on example 7 and 8, you have a single log, and you need to write it in the most expanded form using these properties backwards, I guess. So, number 7. First of all, log base 5, all of this stuff, there's different ways to write it. How do I do it in the answer key? Okay. So the first thing I'm going to do is all of this stuff is being raised to, you have the cube root of all this stuff. So that means you actually can write this as 1/3 log base 5 of 4xy squared. So that's the first thing, and that's not the final answer, but I just took the cube root, which was a fractional exponent, and I wrote it as the coefficient. So again, let me do it here. 4xy squared was all being raised to the 1/3. So that means that this exponent of 1/3 can become the coefficient. Now what I can do is I can break all of these 4x and y squared. Those are all being multiplied, like 4 times x times y squared. So I can break those into individual logs by adding. So for example, this is going to be, first of all, there's a 1/3 log base 5 of 4 plus a 1/3 still log base 5 of x plus a 1/3 still log base 5 of y squared. So far this is correct. I've expanded it into 1/3 log base 5 of 4 plus 1/3 log base 5 of x plus 1/3 log base 5 of y squared. Everything looks good except for this y squared here. I'm going to apply that last rule again. So that exponent is going to become the coefficient. So let's just take it from there and put it right here. So now that's the final answer. Or one possible final answer. That would be correct. If you look at my answer key online, it's slightly different because I factor the 1/3 out. You don't have to, but on my key online, it's the answer is slightly different, but it's also correct. We can just leave this one as is. So final answer is 1/3 log base 5 of 4 plus 1/3 log base 5 of x plus 2/3 log base 5 of y. And that's acceptable. Now we can try it again on number 8. you have log base 4 of this stuff. So because you have a fraction, you were dividing y over x plus 1 squared. When you are dividing, you can split it into 2 logs by subtracting. So this would be log base 4 of y minus the denominator, log base 4 of x plus 1 squared. That's almost the final answer. The only thing is that exponent again. I'm going to get rid of the exponent and put it as a coefficient. So now that's the final answer. Log base 4 of y minus 2 log base 4 of x plus 1. I'll pause for questions and we can keep going. Okay, so now we'll do our last 4 examples together. The rest of this is just practice. So the rest of this worksheet, the answer key's online. You can do it for practice, but your homework is on the online book. So I guess this is optional here. Okay, so last 4 examples. We're going to use the properties of logs that we just learned to solve these equations. So number 9. On number 9, you have 2 logs here that are both base 6. So what we're going to do is we're going to combine them into one single log by multiplying x plus 1 times x. So remember, when you're adding logs, you just multiply x plus 1 times x. So number 9 will be log base 6 of x squared plus x, because I multiplied x times x plus 1. Equals log base 9 of 9 is an integer. You need to recognize that as 1. That's the number 1. If you can't recognize it, then you can write it as exponential form, and then you'll see that it's 1. So now that I have a single log, I can change it to exponential form. So this is the same thing as 6 to the first power equals x squared plus x. And this is just a quadratic equation that can be solved by factoring. 0 equals x squared plus x minus 6 plus x plus 3 x minus 2. So x is going to equal negative 3. X is going to equal positive 2. Okay, now you need to check for like the reasonableness of your answers, because with logs, they have a restricted domain. So let me write you the restrictions. When you have a log base b of x, here's your restrictions. The base has to be greater than 0 and not equal to 1. So your bases have to be positive and they can't equal to 1. The stuff that you're taking the log of, like the stuff in parentheses, so this x, that has to be positive. So it has to be greater than 0. It can be 1, but it just has to be greater than 0. So when it comes to checking these answers here, we'll start with negative 3. It's possible for your answer to be negative. Like it is possible for x to be like a negative answer, as long as when you go back and plug it in, you get a positive value. So let's start with negative 3. So if you plug x here as negative 3 plus 1, well, that automatically is just going to be a negative 2. So you can't do log base 6 of negative 2. Or I guess we already had an x right here, so obviously, yeah, x can't be -3 because you can't take log base 6 of -3. So that's not reasonable. So now try 2. If you plug in 2 here, 2 plus 1 is a positive number, so that's fine. And if you plug in 2 here, that's a positive number, so that's fine. So my answer is x equals 2 only. And I will just keep trying and practicing these. So let's try it again on examples 10, 11, 12. Number 10. Log base 4 of x minus 4 equals log base 4 of 5 minus log base 4 of x. These two logs, since they are the same base, can be combined into one single one. And because you are subtracting, that means you're going to divide 5 over x. 5 over x equals log base 4 of x minus 4. And here, since you do have two logs that are the same base, you can just drop the logs or cancel the logs and set x minus 4 equal to 5 over x. This equation can be solved by cross multiplying. You can just multiply x minus 4 times x and 1 times 5. So let me do x minus 4 times x. X squared minus 4x equals 1 times 5. 5. And then again, that's just a quadratic equation that can be solved by factoring. Let's put it over here. X squared minus 4x minus 5 equals 0. Minus 5 plus 1. X minus 5, x plus 1. So x equals positive 5. X equals negative 1. No. Don't automatically cancel the negative 1 because it could work. It depends on the situation. So negative 1. Plug it in for x. Yeah, negative 1 is not going to work because if you plug it in here, negative 1 minus 4 gives you a negative number. Or if you just straight up plug it here, you can't do log base 4 or negative 1. So that one is extraneous. Let's try 5. 5 minus 4, that's going to give you a positive 1. That's acceptable. And log base 4 or 5, that's acceptable. So 5 is the only answer. Sometimes neither one of the answers will work, and then you would just put no solution. For now, 5 works. So again, sometimes both of the answers are extraneous and you can just put no solution. So let's keep practicing. Number 11 and number 12. Let's see what's going on. Log base 2 of x plus 2. Log base 2 of 5. I can combine those into one single log by multiplying x plus 2 times 5. 5x plus 10. Now I can change this to exponential form. So 2 to the 4th power equals 5x plus 10. That's a linear equation that you can solve. 2 to the 4th is 16 minus 10 can be 6 equals 5x. X is going to be 5/6. No, 6/5. And then make sure you check it to see if it works. So if I plug it in here, 6/5 plus 2, that does give you a positive number, so it does work. If for some reason there was like a minus 2 here, 6/5 minus 2 would have been a negative number, so that would be like a no solution question. Okay, this one works, so my answer is 6/5. Now we got one last one to try. Log base 10 of x plus 11 minus log base 10 of x plus 2. Those can be combined into one single log by dividing x plus 11 over x plus 2. x plus 11 over x plus 2 equals log base 10 of 5. Just like example 10, since both of those are just log base 10, you can drop the log. And set x plus 11 over x plus 2 equals 5. Which can also just be solved by cross multiplying. So cross multiply and solve for x. X plus 11 times 1 is x plus 11. X plus 2 times 5 is 5x plus 10. And then you can solve. I think it's 1/4. 1/4. And then just make sure you check to see if it works. For these logs, you're supposed to check for extraneous solutions. So if x is a fourth, 1/4 plus 11 is positive, so you're good. 1/4 plus 2 is positive, so you're good. So it works. 1/4. So now, that's today's lesson. Your homework is the online book. On the online book, you'll need these properties of logs and this one here, which is called the change of base formula. You'll need this one too. So do your homework. These questions down here, those are just optional, but these are the kind of questions I would give like on a regular year, like during a quiz or test down here. So you should try these for sure as well. But that was it. Let me know if you have questions.